Right folks, part 2. In the previous video we just configured OSPF within the actual core of the ISP. Similarly, we also had configured MPLS within the core. So we actually have complete connectivity between the edge here and the edge here. The next part, what we need to configure is to configure VRF. So if you don't know what VRF is, it will essentially try to conceptualize it as VRF being a kind of VLAN for layer 3. That's the best way I've heard it described to me. So when you look at this and you see that this customer and this customer want to use the same IP address space, and you think, well, you need to pick one because this router can't have two interfaces within the same network. That's not how it works. It overlaps. It will just tell you can't do that. Actually, you can do that. This is where VRFs come in, and it's going to essentially allow us to have, each customer will have its own little routing table effectively, because the global routing table will actually be completely independent from the VRF routing table, and we'll see that in action once we configure it. So I think the best thing to do right now is to start and configure it and explain as I go on. It might make it a bit kind of easier to conceptualize if you've never seen it before. So let's go and do router 2 here. And like I say, what we're going to do is just, you could give it, I don't know, a lot of different names. Say the customer was, not that it would be, but let's just say the customer was Google and the red customer was YouTube. You could call the VRF Google, VRF YouTube, or VRF customer A, VRF customer B. All fine, completely legal, can do that. For simplicity and for the kind of, so you can visually see it a little bit easier, I'm just going to call the VRFs after their actual colours. So we've got VRF blue here, VRF red, VRF blue, VRF red. So that's just going to be the simple format I'm going to use, keep it as basic as possible. So IP VRF, and you'll see we can put in the word. So now we're in the VRF configuration mode. What we need to do now is to configure an actual route distinguisher. Now the route distinguisher will be made up of an autonomous system number and an actual unique number, which will actually specify which VRF we are. So in the case of the core here, when it comes to configuring BGP, I think we'll call this autonomous system number, what, I don't know, 150. Okay, so we'll use VRF 150, the route distinguisher will be 150, and in the case of the blue one, it'll be 152. In the case of the red one, it'll be 153. So we'll do RD, and if you look, question mark, ASN, that is the autonomous system number. Again, we're going to use 150, pretend that's what it is. And we're going to call this one 2. Now the next thing we need to do is to configure the route target, and we'll do route target both to specify both importation and exportation. So we'll do route target both, and again same number, 152. Simple as that. We'll exit out of that. We'll do IP VRF red this time, and we'll also do route distinguisher 150. This time it's going to be 3. The route target, again for both importation and exportation, we're going to use both, but I'll just show you, you can just specify one or the other. And we're going to do 153 again. And that's that. So the first thing which I'm going to do is just, again, just for posterity, I'm going to go into the interface, gigabit 02. And the IP addressing will be 172.16.1.1 here, 1.2, 1.1 here, 1.2. So essentially the ISP will have the .1s and the edge, customer edges will have the .2s. So I'll do 172.16.1.1. Oh, IP address, John. 16.1.1. And we'll no shut that. And if we go into our show IP route, there you see it there, okay? Now, you probably know what's going to happen here, but I'm just going to show it. Gigabit 03. We want to have the same IP address. What's going to happen? It's going to say, well, it overlaps. So 1.1. Overlaps, get an issue here. So what we're going to do is configure each interface into its own VRF. By doing that, it will be completely segmented and essentially isolated from the global routing table, and we can actually separate them completely such that we can actually configure those IP addresses without duplication. So we'll do interface gigabit 02 and we'll do IP VRF blue, and we'll do IP address and just pop, or rather, sorry, not IP address, we'll go into here, we'll do interface gigabit, and we'll do IP VRF forwarding blue, should I say. Okay, now you'll notice this, IPv4 has been disabled. It's essentially stripped the IP address off because we've put it into a new VRF. So we'll just reattach it. We'll do 172.16.1.1. And that's that. Now if we do a show IP route, where is it? Show IP route connected. It's not there because it's not in the global routing table. If we do show IP route VRF blue, it's now in the VRF blue routing table. So similarly, if we go into gigabit 03 and we do IP VRF forwarding red, strip that again, we'll do the same IP address, and again we go into the global routing table, neither of them are there. If we do show IP route VRF red, however, it's also there. And if we just do a basic show IP interface brief, both will be there. So you see them there. So what we'll do is we'll move across here and we'll configure the same thing on router 7. So let's go and we'll do configure terminal and we'll do IP VRF blue and we'll do a route distinguisher. Again, same again, 150, and we're using 2 for the blue one. We'll route target both for importation and exportation. 152, we'll exit U, and we'll do IP VRF red, route distinguisher, 153, route target, and we'll do 150, route target, both, 153. Now let's go into the interface and put them into VRF forwarding. So we'll do interface gigabit 02 and we'll do IP VRF forwarding blue. So this is this one here. We're going to configure it with the 192.168.1.1, and again, I can't stress this enough a bit, I really should just say this again, these absolutely 100% do not have to match. It's just to show the kind of the flexibility that VRFs offer. These can be completely separate. It's just to show you that if you want to match them up, because they're completely segmented, you can do. So don't think you've got to match these up. So we'll do IP address, and we'll do 192.168.1.1. And we'll no shut U. And we'll also go into interface gigabit 03 and we'll do IP VRF forwarding red 192.168 and we shall do 1.1 again. Right, so now we've actually configured our VRFs on them. Now from the point of view of the actual customer, they don't need to know anything about the VRFs. They're not going to be VRF configured at this side. They know nothing. They're just going to configure their actual OSPF and it'll just form an adjacency. Same again, adjacency will be formed here. So I think before we just do, should we do these first? Aye, we will. We'll just do these first. So we'll go to this one here, which is going to be number 1. And we'll configure, we'll make this interface gigabit 02, and it's going to be IP address 172.16.1.2, and we'll no shut that. So see if we can ping this interface up here, move this out the road. So these are now both in the same network. This is on VRF blue. This has no VRF configured. Can it ping it? Well, yes, it can, because this does not need to know anything about the VRF. It's completely on the side of the provider edge here. So 16.1.2, ping its own address first. That's fine. Now let's try to ping the edge. And it's fine. No issue there. We'll also configure a loopback of 1, all the ones, with a turn mashing the keypad like I said. 255. Okay, so they're up, and let's go on to router 3, which is this one here. And again, it's just going to be the exact same IP address because they're both sharing them on this one here. This is customer B. Customer B wants the exact same IP addressing, and it's on gigabit 03. So it's 172.16.1.2. And it's also going to configure a loopback of all the 3s. And let's ping this interface. And we'll do ping 172.16.1.1. Yep, that's fine. So we'll do these two there, and then we'll move on to BGP. So what one's this? This is number 8. This one here. Customer edge 2, and we'll do interface gigabit 02. We'll do an IP address, and we'll do 192.168.1.2. Keep mashing this keypad. So bad, honestly. Okay, and we'll do in loopback 8. IP address, all the 8s. Show IP interface brief, and we'll do 192.168.1.1. Try to ping this loopback of the edge, and we have connectivity. And similarly, if we want to go on to number 9, same again, customer B also wants the same IP address. It's going to be on interface gigabit 03 though. 192.168.1.2. And we'll also configure loopback 9 just so there's a bit of distinction. Show IP interface brief, and we'll ping 192.168.1.1. Okay, so that's that fine. I think, yeah, we will actually. I'll just configure the OSPF. Okay, now, this here, we're going to have two different instances of OSPF. This is going to be OSPF process 2, OSPF process 3, okay, just so you know. And from this side it doesn't matter, they don't need to match, these can just be OSPF process 1, but from this point of view they're going to be separate. We've got OSPF process ID 1 running through here, 2 here, 3 here. So let's do OSPF process ID 1. Now the router ID is going to be different, because we've got the router ID is all the 2s here for this process. So what I'm going to do is I'm going to use the router ID of the 172 network, but we can't use them both in the same one, so to distinguish it I'll actually just make it match the target router. This is router 1, so I'll make this 172.1.1.1. Again, there is no, you can make this absolutely anything. I'm just doing it just for my own oh, why am I in router OSPF 1? That should be router OSPF 2. Just keep that the same, don't want you to change. Router OSPF, actually I'll do a show IP, no I'll do that first, OSPF2. Okay, now so the router ID is 172 for this one. Like I say, it could be anything you want, this is the format I'm choosing to use. I'm on the 172 network, so I'm going to do 172.1.1.1 for this one, and 172, and because it's a router 3, 172.3.3.3.3. It could be anything you want, but that's the way I'm doing it. Now the network we're going to advertise here is going to be 172.16.1.0 with a /24, so that's going to be the wildcard mask. Again, area 0, that's all fine, and that's that. Now for this one here, we're also going to configure router OSPF 3, and for this one we're going to use 172, and we'll just use, like I said, the target will be 3, so I'm going to use all the 3s. And the network, we're going to advertise the same network, so 172.16.1.0 /24 mask and area 0. Let's move down to the customer. In fact, you know what, we'll do number 7 first. We'll do all the edge one first, get that out the road. Same again here, we're going to do router OSPF 2. Again, it's me mashing keypads. Router OSPF 2, and we'll do a router ID. For this one is going to be, we're on the 192 network, so we'll do 192.8.8.8 for that one, and 192.9.9.9 for the ID for the different ones. So we'll do 192.8.8.8, and I'm just laughing at my type on this keyboard, and it's a /24. Okay, and for this one we'll have the process ID of 3, and the router ID is going to be 192, and it's going to be all the 9s. Again, the network will be the exact same because both customers have got the same network address. And that's that. So now we're going to act like we're the customers on the site. So let's go to these ones, and the customer's just going to do a basic OSPF configuration. They don't need to worry about the VRFs, nothing. So let's do customer site. That's going to be number 1. And it's going to do a show IP route connected. And we're going to do a router OSPF 1, like I say. The router ID for this one can be all the ones. And the network is going to be 172.16.1.0, and our adjacency should pop up. And we'll also advertise the loopback. Why is that not up? Where are we? 1.0, check that's right. That's fine. Just double check. Number 2. Do show IP route. Oh, VRF rather. Show IP route. Oh, do you know what? I forgot to do? This is a good lesson actually. This is a real good lesson. What I need to do is see my OSPF. I'm actually like, this is quite good. I've done this. This is like a good thing not to do. What did I do wrong there with my OSPF? It was just when I went to look at the routing table here that I realised what I did was I just did basic OSPF. Now, I thought I was doing them by separating them by having different processes, but what also do I need to do? They're in different VRFs. So, do you know what I'll do? Let's take these off. We'll do router OSPF 2, no router OSPF 3, and let's go to, and we'll do no router OSPF 2, no router OSPF 3. Okay, we'll leave these, they should be fine. So what I'll do is I'll go back up to router. Now the different configuration what I need to make here is router OSPF 2 VRF blue. There we go. And the router ID, we're going to keep the same format. It's going to be 172.6, or not 16, we're going to have 1.1.1. And we'll make the network of 172.16.1.0 and make it area 0. There we go, adjacencies up. And we'll also do router OSPF process ID 3 VRF red. We'll make the router ID of 172 and we'll make it all the 3s. And again, the same network will be advertised, 172.16.1.0. That's it. And let's go to customer B, which is number 3. Okay, so let's do a conf t. We'll do router OSPF 1. I'll make the router ID all the 3s. And I'll make the network 172.16.1.0 with the /24 mask. And we'll also advertise the loopback. We're in two-way state. Just going through the down attempt init, two-way xstart exchange loading, and full should come up. Any minute. This is why I like EIGRP, because EIGRP is like that. As soon as you do the adjacency, it pops up instantaneously. OSPF, for all its greatness, it's a little bit slower for an xstart. That's us now up. So we're now in full. So that's fine. Let's do the same thing and move over to router 7. Actually, we'll need to do that again, and the 2 customers here. So we'll do router 7. And remember our actual VRFs, super important. And we'll do VRF blue. And we'll make the router ID 192 and we're going to match it to the 8. Again, this does not have to have any kind of specific format. This is just purely for my own kind of, just for keeping it simple for me. So we'll do network of 192.168.1.0 and we'll make that 255 area 0. And we'll also do router OSPF 3 VRF red. Make the router ID 192 and we'll make that 9s at the end here, and the network's going to be the exact same, 192.168, and we shall do 1.0 area 0. Close you. Now let's go to the customer sites. The customer site will be router 8, and again just a basic OSPF configuration here. Up. The next one now. Number 9, we'll do conf t router OSPF 1. Router ID is going to be all the 9s for this one. And we'll do network 192.168.1.0. Area 0, and we'll advertise the loopback. Up. Okay. I'm going to do an enable conf t router OSPF 1. Router ID is all the 8s. And we'll do a network of 192.168.1.0. Area 0, and we'll do all the 8s. Okay, show IP route. Okay, doke. That's fine. Now, if we go into, say, for example, router 2, and again, if we do the basic show IP route, we're going to see nothing about these networks here. If we do show IP route VRF blue, we'll see that network plus the 1 loopback, which is on here. If we do show IP route VRF red, we'll see the exact same thing here, except this will be all the 2s. Let's just show you that. All the 3s, sorry, that's number 3, that's number 2 rather. Again, on this one here, number 7, we do show IP route. Nothing's there for those networks. Show IP route VRF blue. We now see that with all the 8s, and with the red one, we're going to see the exact same, but all the 9s. There you go, but all the 9s. So that's VRF configured. The next thing we're going to do is to configure BGP between these routers. It's going to be iBGP, internal BGP, using autonomous system number 150. We'll do some things with address families, with VPN and with IPv4, and then we'll also do our actual redistribution so that we actually have full connectivity and we have the ability to dynamically exchange routes between customer sites, and that'll be that. So we'll call this the end of this part, and I'll see you in the final part very shortly.